Hi again. I have the utmost pleasure of being able to introduce two of my friends from SDT Ultrasounds. I'm always on the same frequency with these guys, always. So I'm talking about Allan Rienstra and Haris. Haris is going to forgive me for not being able to pronounce his last name properly. Alan will help me out there. So they are going to be doing some rapid fire questions about reliability. Now, this is going to be very interesting. So take some notes, get ready for some questions, and let's hear what these guys have to say.
Good morning, good afternoon, good evening, good whatever time of day it is for you. And here we are at the LRVS, the Lubrication Reliability Virtual Summit. Thank you so much for Sanya and her team for inviting myself and Allan Rienstra and my colleague Haris Trobradovic to present to you. I'm coming in from Canada. Haris, where are you?
I'm coming in from Croatia. It's a beautiful piece of land in Europe. My name is Trobradovic. I'm FLM at SDT, proud member of SDT family and team. And let's keep it short here.
Excellent. And I'll keep it short as well. My name is Allan Rienstra. I'm also the frontline manager with SDT Ultrasound Solutions. I'm based in Cobourg, Ontario, Canada, just outside Toronto. And today, for our LRVS presentation, we're going to talk specifically about bearing grease replenishment, bearing lubrication, and optimizing the entire lubrication task. But we're going to do it in a way that's a little bit different than what you might be used to. You'll see that we don't have any fancy PowerPoint slides behind us. You just got my beautiful friend from Croatia, my not so beautiful face in front of you. And we're going to do what's called a rapid fire concept. So in a rapid fire concept, Haris is going to present me with a couple of topics on lubrication. I'm going to address those topics to the best of my ability. If he's a bit of an expert around this topic, so if he thinks that I'm not quite describing it the way I should, he might interrupt me. If I'm doing a good job, he might say good job. He may add a few comments. Then it's going to be my turn to give some topics to Haris. And same thing, if I don't like what he's saying, I'm going to interrupt him. If I like what he's saying, and I'm pretty sure I will, then I'm going to tell him good job, and I may add a couple of comments as well. So we're going to go back and forth, and we got 4 topics. And Haris, I believe the first topic is for me.
Yeah, I have an interesting topic for you. So there are so many things in lubrication that can go wrong. Of course, some of them are known, some of them are not so well known. But there is always this idea that we need to put more grease. We need to put more grease because dry bearing is a problem. Now, please tell me, why too much grease is actually worse for the bearing health than not having enough?
Why too much bearing grease is worse? Well, first of all, when you put too much grease in a bearing, you prevent the proper lubrication mechanism from establishing itself. When we put the grease into the bearing, we're not trying to fill the entire cavity of the bearing so that it's choked out. What we're actually trying to do is we're trying to create a wedge. We're trying to create this thin wedge film of oil. And to do that, we have to be very precise about just how much grease we put in there. Unfortunately, the people doing the job in many instances haven't been properly trained, and they're not aware. And so that they think that, well, typically in all of our cultures, a little's good, the more must be better. So they just pump the bearing full. The problem is when you pump the bearing full, you kill the grease. The thickener gets destroyed. You change the viscosity of the grease. You remove all of the space inside the bearing, so there's no way for the heat to dissipate itself. And that heat's a problem too, because every time you increase the temperature inside the bearing by only 10 degrees Celsius, you cut the life of that base oil in half. So imagine 10 degrees and then another 10 degrees and another 10 degrees. And before you know it, the life of that grease is nowhere the way you thought it should be. And that kind of also messes up your intervals. I mentioned the thickener, and the thickener is something that has to be put in place to hold the base oil where it can be fed into what I call the war zone, or where the rolling elements meet the raceway. And then that oil just bleeds out of that thickener. Well, think of that thickener like a kitchen sponge, or a sponge you might use in the shower. You squeeze, and the soap comes out. Well, the kinetic energy of the bearing squeezes that thickener, and it bleeds the base oil into the war zone. If you put too much grease in there, you can't do it. And what happens is that sponge becomes part of the war zone. And when you're in the war zone, you're going to get rolled over a million times a day. And eventually, all of those fibers that are part of that sponge, that thickener sponge, become part of the base oil. That changes the chemical compound of the oil. So now you don't have the same viscosity that your tribologist might have recommended for that bearing. Oh, so many other things can go wrong. When you put too much grease in the bearing, I like to compare this to like trying to run through 3 feet of water. I can't run through 3 feet of water because I'll get tired. When you try to push a bearing through too much grease, you're consuming more kilowatts than that motor needs to. So now you're not only killing your lubrication and your grease, but you're making the motor run in an inefficient energy way. There's my timer.
That's great. I completely agree with you, and there's nothing much to add. Certainly nothing to correct. And I really like that at the end, just as the punchline, you mentioned the energy consumption, because today this is a topic number one besides reliability in general. So thank you for this. Thank you for this explanation. It was really clarifying.
Great. Thank you so much.
I have another question for you. May I?
I'm ready.
For years, tens of years, there were different lubrication practices. So one of them was very famous, called anarchy. Sometimes do something, maybe. And then we had a time-based lubrication. It was considered good. And I agree, it's much better than anarchy because there is some law and order. But today it's not so anymore. Now, can you explain me why time-based lubrication is no longer considered a better practice?
Well, here, it's a great one. It's a really good topic and a really good question, but I'm going to start by disagreeing with you. Time-based lubrication has been around recently, but condition-based lubrication has actually been around a lot longer. 4,000 years ago, the Egyptians were using condition-based lubrication to guide their lubrication actions. They would use duck fat, they'd use water, they'd use tallow, and they used these substances to make it easier to push sledges along the ground. But they didn't just pour the fat down every 100 meters or 100 yards or every 2 minutes, because that would be time and that would be distance-based. No, the Egyptians' cue to add more lubricant was friction. When the sledge became too hard to push, they just added more lubricant to the sledge wheel, to the base of the sledge. So you see, Haris, We didn't invent on-condition lubrication. We've just made it more of an exact science. The Egyptians have been doing it 4,000 years ago. But since you asked about time-based lubrication not being the better practice anymore, it's because we can do better. We have the science to support doing things on condition instead of doing things based on time. Time-based was the best thing that we could do in a period when we didn't have the technology to support it. But now that we have the science, we have the ability to combine condition monitoring with lubrication replenishment. There's two factors that drive replenishment. The first one's replenishment quantity. And the replenishment quantity we know is based on science. We know it's based on fact. It's based on the dimensions of the bearing and so on. The interval, or the time between injections of fresh lubricant, not based on science, it's based on best guesses. And we also call those best guesses correction factors. So correction factors are the things that we use in our formula to determine the interval between grease replenishments. And those are temperature, contamination, moisture, vibration, the position of the asset, vertical, horizontal, or otherwise, and then the bearing type. Well, of those 6 interval correction factors, it's impossible for me to know with any certainty what any of them are except the bearing type and the position. The vibration I can measure, but it changes all the time. Moisture, I can't really measure it unless I do a grease sample, and that could change all the time. Contamination, I don't know. How do you determine what the contamination is in a bearing today? Maybe I did oil analysis a month ago, but I haven't done it in a month. So the contamination's changed. And the temperature is always changing too, especially here in Canada, where we have -40 in the winter and +40. So those, the time base presumes that the machine is perfectly installed, aligned, balanced, nothing's changing. So it's really, to me, their best guesses, and condition-based lubrication is the way. I would like to, I mean, I heard the bell ring, but there's three elements to condition-based lubrication, 3 questions. I didn't get to them. I'll let you get to them.
Let me give you my minute to respond to you. So
okay,
I'll give you my minute so you can continue with this.
Perfect.
Okay. So what
you're going to give me?
Oh,
okay. Sorry, you're going to be my. Okay. Condition-based lubrication begins with 3 simple questions. First one, I walk up to the bearing. I say, "Hello, Mr. Bearing. Do you need some grease today?" The bearing says, "No, leave me alone." Okay. I'm going to go somewhere. I'm going to go have a coffee, or I'm going to go somewhere else and do a different job. But if the bearing says, "No, I'm thirsty. Give me some grease," I'm going to ask him another question. I'm going to say, "How much? How much grease do you want?" "Well, I'm thirsty, but I'm not really thirsty. So just give me a little bit." "Okay, I'll give you a little bit." And then the third question I'm going to ask Mr. Bearing is, "How do you feel now? Did I make you better?" And then the bearing's going to tell me.
Exactly.
Thank you for the minute.
Yeah, you yield back.
Did I use it the way I should?
It was well used. Excellent.
Perfect. Perfect. Anything to add?
No, nothing to add. You explained it perfectly. It was really absolutely clear. Okay. Absolutely clear.
Now it's my turn. I have 2 topics for you.
Okay, shoot it out.
First of all, I know that you're not a guy who likes to have a lot of accolades brought on him, but I think of you as a bit of a master of lubrication implementations. And you're helping me become one as well. And so I know that the most fulfilling segment that we see in our customer's journey is when the data begins to drive his strategy.
Yeah.
But many lube strategists are not aware. They're unaware, or at least they haven't considered which outcomes their condition-based lubrication program should deliver for them. The next topic I'm going to give to you is for them, because it brings focus to the real reasons that we have to pay attention to precision lubrication. So here he goes. Haris, how does lube replenishment data drive the strategic outcome that optimize lube tasks, prolong bearing life, and increase production output? Go.
3 minutes is not enough. I want my minute back. You owe me a minute. So I have
We'll
four.
see how you
Thank
do. We'll see how you do with your 3, but I do owe you a minute.
Yeah, so let's go back to the beginning first. Why we lubricate at all? We lubricate it to increase profit. Basically, step 1 is to increase reliability. So we know very well that monitoring itself doesn't increase reliability. It just gives you information. So the fact that we are monitoring something is not really helping anything. Now, why am I mentioning monitoring? Because condition-based lubrication is actually condition monitoring. And we should switch our mindset into that field. Unfortunately, it should have been done 40 years ago, but it's never too late. So I will just connect it with those 3 questions you mentioned. So does bearing need grease? How much? And is it better now? So when we extract it out from the way you expressed it, we come up with the data. We come with a fact that a certain data, certain information, in this case, ultrasound level, is confirming us does bearing need grease or not. So that's information number 1, and that's a number, that's a data. How much? Well, that's another one, but actually there are other sub-data here. What was the response at what stage? So that's another interesting point. And then, is it better now? So we can, again, it's data. It's something that we call base area. We don't call it baseline because it's never a line, of course. It's a base area. So we can understand what's good, what's bad. We can understand the response of the bearing. So if you really boil it down to basics, it's condition monitoring. Now let's jump back to the beginning again. I want to improve my reliability. So that means I need to have my lubrication excellence on the highest level. Lubrication excellence is a strategy. It's not just a set of rules or procedures. Because if it would be a procedure, it would be a really simple job and everybody would be happy, but it's not so. It's a strategy. It changes daily, it changes monthly. Things do change and we need to adjust the strategy. So how do you drive a strategy? To drive any kind of strategy, you need to have a data. So you need to have a data that says that what you are doing is okay or not okay. And you need a data that tells you if it's not okay, what should be done. Now, to put it really in a perspective of a daily implementation, when we have grease technicians or grease strategists asking, okay, what do I need to do now? So my answer is always very simple, same as yours. Look at your data. I have no idea what you need to do. So, well, we can all play consultants, and that's great, but I'm looking at the same data as he is looking. So that means you already have in your hands all the tools you need to run the strategy. And that tools means how often am I visiting this bearing? Under what conditions the change happens in 1 month, 2 months, or 3 months? I hate that bell. Now,
you have my minute.
Thank you. Then again, I go a little bit deeper and I say under this condition, my grease technician was adding 42 grams, but under some different conditions, he was adding 32 grams. Now, what was the response of the bearing on the first 8 grams and then another 4? It's not going to be the same every time. So little by little, you are getting the medical chart of the bearing, each of them individually. And if data is set and sorted nicely and perfectly, you can just look at it and say, this is what I need to do next. I can afford the luxury of visiting this bearing really not so often, maybe every 2 months. Or I need to do it faster. I can optimize my job. I can optimize by saying the interval can be longer, should be shorter, my quantities are different, and this is the behavior of my bearing. And that's just the beginning.
Beautiful. And going hand in hand with that data, that ultrasound data, we also have our failure modes and effects analysis, our criticality assessment of that asset. All of those play a factor too, right?
Absolutely. This is something we need to do in the very beginning. We shouldn't be doing and taking the grease gun in our hands at all, unless that job is done completely. Because if you want to treat a patient, you need to know something about that patient. Yeah.
Okay, the bell's gone. We have to move on. I'm just going to say one quick thing on that comment though. In my earlier life, I was a basketball guy, and I loved to play and I loved to win, but we didn't win every game. Sometimes we lost. But regardless of whether we won or we lost, we always went back into the locker room and looked at the game film. And I think that the data from our lubrication tasks is just like looking at the game film and analyzing what you did wrong and what you did right.
Yeah, I was afraid for a minute that you will say we go back to the locker room and have a shower and then explain that. But this was very, very educative. Thank you.
Okay, topic number 4. So we all agree that for things to get better, we have to restore the misperceptions that the lube technician is nothing more than a grease monkey. But stigmas can be as hard to change as bad culture driving our behaviors, our habits, and our rituals. Therefore, what I want you to do is I want you to comment on the role that lube technicians play in reliability and how we might remove the negative view that many have towards this noble discipline. So please comment on this topic. How lube technicians can contribute to the condition monitoring teams for better collaboration?
Simple question is by being a condition monitoring team, period. Because the lube tech who is doing condition-based lubrication, he is condition monitoring team. The only difference is that he actually acts immediately. So ultrasound condition monitoring, vibration condition monitoring, you go there, you make your analysis, you recommend what needs to be done. The only difference is that this guy is doing it immediately. So he's doing his measurement. In some cases, instruments like ours is doing complete analysis, recommendations, saying you need to do that. So that's the only difference. Let's be completely honest. He is doing condition monitoring. Nowadays, we have very, very interesting reactions that when you, on one side, you take the lube team that was unfortunately considered as a very low level, not important, and as you said, grease monkeys, which is a really bad thing. Let's not even comment that.
It's a terrible.
And then after 5-6 days of training and several weeks of a little bit deeper implementation, you have this lube team going up and becoming Mr. Grease guy and doing an excellent job. And then very often I have a reaction from condition monitoring team saying, hey, I can also do that. I also know how to do that. Well, why didn't you? Why didn't you do it for all those years? Why were you blessing this to be done based on time if you believe only in condition? But that just points out the similarity that these two teams are doing the same job. They are visiting the same assets. They are concerned about the health of the same assets. One of them is doing some proactive thing that can actually be very dangerous. Lubrication is very dangerous. Yeah. The other team is actually observing, monitoring, and trying to understand what happens. So it's one team. How can we use it? There is a long list, and in 4 minutes, I already take your minute to me. It's far from enough to do that. But the first step we do in
you can't take my minute. I have to give it to you.
Please.
Okay.
So the first step we can do in implementation is basically so for everyone to understand that this is condition monitoring. Now, the clever leader of condition monitoring team and clever leader of condition-based lubrication team can have a short meeting over a coffee and saying, hey, my guy is visiting this bearing every month for XYZ reasons. Why do you need to visit that bearing every month? Well, because my guy is already there. He needs to go there and do it. So let me just transfer this data to you. And then you can say, everything is stable. I have the information because it's ultrasound condition monitoring, early detection. So
now you have my minute.
Thank you. Thank you very much. So that means, well, I can optimize because we never have enough people in condition monitoring. So I can say, great. Now my doctors have nurses. So somebody is collecting data for me. Somebody is bringing all these observations. I can use it to optimize my job. So that means that they will get more time to go in depth, to find the root cause of the problem, to get the proper recommendation, and do all this stuff. And there is additional value. Additional value for every condition monitoring analyst, any technology. I'm not making any difference here.
No.
There is additional value. If somebody tells you this is the condition before lubrication and after lubrication, there is a step one in your analysis already done. So this is what we do in first 2 weeks. So this is not even the first step. It's the thinking about the step. And we can already do a lot of optimization.
So many lube tech. Yeah, you have to. Otherwise LRVS will kick us off. But so many lube technicians call me and say, hey, I've heard about ultrasound for greasing bearings. Help me. And the first thing I'll say to them, are you prepared as the lube technician to become a condition monitoring technician as well? And they look at me like I'm crazy. So this is a real, it seems silly, it seems crazy to us because we speak and breathe it every day, but this is a real paradigm shift for lube technicians.
It's a huge change.
And that's why they need us as mentors. Haris, you answered that one perfectly. You really addressed that topic well. I want to give you 30 seconds just to wrap up your thoughts on these topics, or maybe give some advice to the audience.
Yeah, so all we talk about here is how to do the job. Now, always a good question is why to do this job in the first place. And there must be a constant a sign out there that lubrication is money. Lubrication means profit. We don't lubricate to make machine go smoother. That's a tool. We lubricate machines for the company to get a higher profit. So express lubrication in profit to get attention from everyone, and then it really makes sense. And then change the culture, build the foundation, and then go up.
Change the culture. I'm going to wrap up by saying poor lubrication practices contributes to unreliability more than any other maintenance sin. And I call it a sin, even if it's a sin that we commit without malice, without bad intentions. But it happens out of ignorance, and it happens because there's an absence of direction from management. And because the esteemed role of the lubrication technician has been degraded with monikers like grease monkey. Therefore, as owners and guardians of our assets, we have to do everything in our power to restore the glory of the lube tech back to where it once was and where it belongs. Haris, this has been, again, this isn't the first time we've done this, and it won't be the last, but it's been an absolute pleasure to have you here and to share your wisdom and knowledge. Thank you so much.
Thank you, Allan, for having me here.
Great. And thank you to the Lubrication Reliability Virtual Summit for this important conference, and for inviting Haris and myself from SDT to come on and have this discussion. So long, everybody. Thank you very much.
Bye.
All right. So we had a great session with Allan and Haris. I know you all have a lot of questions for them. We've got 2 minutes. Let me see if I can put a 2-minute timer on Allan now. Now I know
no more timers.
No more timers. Oh boy. I know Mousa had a very, very interesting question. Time-based lubrication versus ultrasound methods, condition-based. What is the effect on the bearing lifetime?
Yeah, well, I mean, anything that we're going to do to our assets is to have a positive impact and extend that life. It's really, as I said in the comments, 40 to 80% of premature failures are rooted in the bad things that we do with lubrication. And that's not just over and under greasing, but it can be contamination. It could be not getting to the bearing in time. And a lot of times, as in Haris's last segment, we talked about time-based lubrication. Well, we don't know that the interval that's been set by the CMMS is the right interval. It might have been the right interval on the day that it was calculated, but that calculation was done based on 6 correction factors. And those correction factors change: vibration, humidity, contamination, temperature. All of those correction factors are a single point in time. But go ahead 6 months, go ahead 12 months. Here in Canada, we have 4 distinct seasons, so temperature is always going to fluctuate on an outdoor asset, right? So the base calculation we use to determine the interval between lubrication tasks is not an exact science. And so that's the first thing that evidence-based ultrasound will allow us to do, is to actually go to the bearing and apply grease based on friction, not fiction.
Okay, we have a quick question from Kevin. Can you repeat your statement that started with lubrication affects maintenance more than, I don't know, do you remember that statement, Allan?
Not specifically, but I'd like to revisit it and say that lubrication, in my mind, is a proactive task. It's not a maintenance task. Lubrication contributes to the reliability of the bearing and the reliability, therefore, of the asset. But I don't think of it as a maintenance task. I think of a maintenance task as something that's done to maintain and repair. And I think of lubrication in a completely different way.
Which is a good way, though, Allan. A good way. I know we have a lot of other questions, but we are out of time. So I know Allan wants to meet some of you virtually. What I'd encourage you to do, go over to the video room section that we have. And right now we have an hour break. So
Nice.
go into the video room and the hangout room and just hang out with Allan, you know?
That's
And
great.
ask him
And
as
I
many
know, I think I
questions
know how to
without
find
the
that.
timer. Allan will not be on a timer when you meet him in the video room.
No,
So definitely meet up with him there. And thank you all so much for joining us. Allan, thank you for your time today and for
thanks
all
for
of your
having me.
knowledge. All right.
Appreciate it.
Bye, guys.